Hello, everyone, and welcome back to A4Q Testing Summit. My name is Atefe Amlashi, and I'm your host for this session. For this session, I'm pleased to introduce Matthias Hamburg, a longtime expert in software testing and quality assurance, actively involved in both German Testing Board and ISTQB communities. Matthias was for a long time was a chair of ISTQB Glossary working group. In today's presentation, filling the test automation gaps with AI, lessons from the ISTQB Glossary project, Matthias will share a real life case study showing how generative AI and model-based testing and automation can work together to improve testing efficiency and effectiveness. Hello, Matthias, and welcome. As always, I encourage everyone to participate and stay engaged. Ask your question or share your feedback with us via chat or in the comment section. And do not forget to vote for Matthias if you liked his presentation. Matthias, the stage is yours.
Thank you, Atefe. And here we go for yet another presentation dealing with generative AI. And generative AI told me it's better to call it bridging the gaps than filling the gaps because it sounds better. So let's talk about bridges. Just a short introduction of myself. I am, as Atefe mentioned, since many years in the business of IT testing. I started my career in 1986 as a consultant in the IT industry and retired in 2020. But I'm still continuing my engagement as a volunteer in the German Testing Board and ISTQB. And my professional focus areas are still maintaining and being the product owner of the ISTQB Glossary application. And so I am stating the requirements, I am specifying them, and I am studying. I'm also the project lead of the development of the latest version of the ISTQB syllabus Advanced Test Analyst about test techniques. And we also wrote a book with my dear colleague Adam Roman from Poland to support these certifications, which will appear in August this year. So it's not yet on the market, but it's announced for August. And I also practice test process improvement, assessing the maturity of the testing processes in large companies throughout Germany. I also have some professional hobbies. So I'm very interested in automated dynamic testing. In my industrial practice, I also practiced model-based testing and test automation. And I'm also consulting a startup company in Hungary called Harmony, which has this aim to automate completely the dynamic testing with the aid of generative AI. So we'll see how it works. Today, I would like to tell you about our approach to generative AI, using generative AI in test automation. So what's the issue? Traditional test automation is insufficient. It has been shown by large surveys in the industry, for instance, the World Quality Report a couple of years ago. And now when the generative AI is widely used we start to use it widely, of course, we can ask ourselves, how can we improve that? And we don't want, in my approach, to reinvent the wheel. So we want to retain the traditional test automation practices, but bridge the gaps within this testing process with the aid of generative AI. So let's have a look at how this actually works. In the first part, I will shortly outline the approach that we use and the case study, the glossary application. Then we will focus on the two gaps to bridge. So that's why I chose the picture of the Margaret Bridge in Budapest, which has two parts. So if we swim across one branch of the river Danube, we will not be done. We will need to swim across the other part as well. So we will have to deal with test analysis and test implementation, and then, of course, the conclusions. So let's look at the testing process, or the dynamic testing process. ISTQB differentiates 7 activities within it, and we can subdivide them into the swimline of dynamic testing and test management. And what I am dealing with is only the dynamic testing. So we'll not discuss how to support with generative AI the test planning, the test monitoring, control, and test completion. That's a different topic. You can, and it makes very much sense, but we will focus on test analysis to test execution. So going the path from the test basis, which is in my case the requirements specification, to the test results. Now, when we talk about automation, of course, automation of the test execution is standard practice. We have the tools in place like Selenium or Playwright, and we have also technologies or methods like keyword-driven testing to make it maintainable. So this is not the problem, and this has been mentioned in the survey as well, that almost all companies dealing professionally with software development do it. The second part, which can be traditionally automated, is the test design. So here, in test analysis, we create test models, and from the test models, we automatically derive the test cases. Now, this is called model-based testing because it starts with modeling. And this model-based testing is an issue. It's not really used very often, and it has several reasons why it isn't. But one of the reasons is that the subsequent step of test implementation, where you map the keywords onto the test interface and where you select the test data and make abstract test cases into low-level test cases, this step is not traditionally automated. So you generate something, and then you have to manually work on it, and then generate something else. That doesn't really work. So we have two gaps to bridge here: the test analysis and the test implementation. So this is the starting point, and then let's look at how generative AI can help us bridging these gaps. The case study I'm talking about is the ISTQB Glossary application, which supports users in searching for and displaying the details of terms used in ISTQB, of software testing terms, of course. And this is a web-based dialogue application. It looks like very simple, but it isn't. It has some complex aspects. I will show you one of them, one feature, just for understanding. And I'm using in the test acceptance testing the test tool MBT tool Harmony, originally just focused on model-based testing, but of course enhanced by now by generative AI, and they use the Claude Sonnet 4.6, and it is also connected with the test execution automation tool Playwright, which is one of the standards nowadays. What is the test plan? So what was I dealing with? At the beginning of this year, in February, we released a new version which had to update all the frameworks used in the application. This means the database management system, the programming language, the application framework, and we said, okay, we won't change any features, so the functionality will be the same, the features will be the same, but the platforms change. So this means I have no idea on where defects can occur or failures can come up. And that's why I decided to conduct a comprehensive regression testing of all features and to automate as much as possible, because you can imagine we are a voluntary organization. People don't have much time. So I cannot collect much human resources to run the tests. What was our luck was that we didn't need a test oracle, or so to say, the running live system served as our test oracle. So we could immediately verify if a result is correct or not. So this is the task. Now let me show you one single feature of the glossary application. When you invoke this web page, the glossary application, then of course you have to answer this mandatory cookie consent. And after answering the cookie consent, which doesn't influence much the functionality, then you will see as the first page the list of all glossary terms in our glossary. In this example, 590. Of course, not all of them. It's a long list, and it's loading if you scroll down. Then you can search for some texts in the glossary, like bug. And the application will show you different attributes, like the name or the synonyms, attributes of an entry for a term, in which this text will occur. In this case, we have two matching names, bug hunting and debugging, and 4 terms which have synonyms, which you can't see on this screen and on the result list, but if you go into the details, you see that defect has bug as a synonym and so on. Okay, so this is simple, but then you can click the blue button to change the search settings. And in the search settings, one of the features is that you can select the attributes of a term in which you want to search for your text. And I will deselect the name and I will select the definition. So we'll only search in abbreviations, definitions, and synonyms. When I click on the apply button, you might have noticed that there are apply and reset buttons. There is also a cancel button in the button, which is unfortunately cut off here. So if I apply these settings, then I expect a new list. In this case, only 5 results, because in the definitions, bug only occurs once. And of course, the matching synonyms reappear here, all 4 of them. So this is a typical scenario which we can test. Now let's look at test analysis. How can we generate test models with generative AI from a specification? If we look at test analysis, it includes a list of basic activities or detailed activities. Here is a BPMN picture from our book with Adam Roman. And you can see that you start collecting relevant information. The main part of it will be in the test basis, which in our case is the requirement specification. And you might have product risk registers, test plans, and other additional documents. Then the first important step is to evaluate testability. And so we use the test basis as user prompts, and we can also use the additional information as user prompts, or alternatively for retrieval augmented generation, RAG. But it is very important, especially if you work with generative AI, to evaluate the requirements for testability, because if the requirements are ambiguous or have some gaps or have some other issues, then GenAI will generate wrong test cases and will amplify these problems rather than removing them. Okay, and then if your test basis is proper, then you have to define either test conditions in one case and conduct reviews, or create test models. That's what we want to do because we're going for model-based testing. So the knowledge in how to evaluate testability and how to create the models must be in the system prompts. It must be independent of the test basis. You must be able to use it for every application. And this is what I'm expecting from our GenAI system. It can include, for instance, TMAP. The testing method TMAP includes a large list of testability checklists, depending on the test techniques you want to use, and the creating the test models will, of course, depend on the test techniques you want to use, whether you want to go for equivalence partitioning or for a state-based model. And this component must also be able to decide which are the best test techniques to apply here. Okay, so let's look at our example. In our case study, I have a requirement specification for searching in attributes. I don't want to read it aloud, but it explains that the search settings include the attributes in which you can search, and you can, we have a default setting, and you can enter text, and then these attributes will be used. And in the end, it also says that we have these 3 buttons to cancel the search settings or apply the new search settings or reset to the default settings. Now, when I start generating test cases, I'm expecting from my system to evaluate the testability first with GenAI. So that's what it does. I import in these requirements that I mentioned before, and it prompts me to analyze, to let it analyze the requirements. I click on this button, and I get, surprisingly, 4 commands. And these commands are important. You have to take care of these commands. Because, for instance, it says the behavior of the select all toggle is ambiguous. So it's not specified whether if I click on select all, those that are selected will be deselected or not, or what happens. And it gives you also a suggestion how to fix it, because it assumes something, that you meant something, but it's not sure. If you don't run this review, then it will use its assumptions, which might be right, might be wrong, and generate accordingly. So I don't want to explain all the 4 commands, but these are important commands, and it must be a well-trained model, that because otherwise the commands will not be good. And I have the option to accept some of them, meaning that I adjust the specification to make it unambiguous in this case, and I can also discard some of them. And after having done it, I rerun the analysis, and it says, okay, no anomalies left, 2 discarded anomalies, as I mentioned before, and we can continue to design. And then I click on design, and I get the test model. Right here, I expect from the system, from the AI model, that it collects all the relevant information with generative AI, including, for instance, the end states of previous features, such that I don't have to start from scratch from the cookie consent with every test case. It's in a different feature. This is feature 3.2.1, searching by attribute, and it should collect the relevant information and use it in its model. This is, by the way, the Harmony model, which is looking like a scenario with forks and joins. We can't see joins here on this screen, but that's how it works with test steps in between. Okay, and now I also expect from the GenAI to identify and justify the applicable test techniques. And this is very important because I don't want to test everything by the same test technique. It's not really addressing the real risks. So in this case, our system first studied whether there is state-based behavior. Is there a state-based model? And it decided there is one because there are some actions which act differently, bring a different result depending on the state of the system, like click apply button, whether you selected a non-default settings or the default settings, there will be a difference and so on. So this is something we should expect. And we should also expect that the test models generated contain elements which are traceable to your test basis. In this case, you can see in bold the requirements in the specification, and that the requirements are also covered, not just the model. Right? So this looks all fine. And in addition, in the model, it should also explain why it does it. So how it applied the test techniques. In this case, here you can see comments where it explains which state transitions have been covered by this test case. So in the end, we generated a model, and in this tool, like a typical model-based testing tool, it generates on the fly the test cases as well. In our case, we received 15 different test cases, which you can then execute at this point in time manually. You could sit down at the application and execute and say, okay, verify if the app starts with the default search settings and so on. Right, so we arrived at a good result. Now, what about the efficiency in this test analysis? Well, the timings are quite impressive. GenAI analyzes an average feature of the size I've showed you in about 1 minute. The test analyst, so me, for instance, has to review the findings, of course, and to work on them and to rewrite the requirements. But if the requirements or the specification is good enough, then you're done in 30 minutes. This is, of course, independent of GenAI. This is the manual work, the human work. And then GenAI verifies it in another minute, and you're done. Generating the test model is also as fast as the analysis. So GenAI can generate a model with 10 to 20 test cases. In our case, it was 15, also in about 1 to 2 minutes. As a test analyst, you need to review it. So you need an average of 30 minutes to review the model. But this, compared to what I'm used to doing it manually, I estimate it would take me half a day, 4 hours. So it is really 4 times faster that I'm done. I don't have to write the test cases or the test model. It's the GenAI which writes it for me. I only have to review it. Let's look at the test implementation. So now we generated the test cases, and these are the main input now for test implementation. The test cases are high-level test cases, so they have are on a high abstraction layer, and we have to deal with them. Now, these are, again, the basic activities in test implementation listed in our book according to ISTQB. You have to organize the test cases into test procedures, which in our case should start from accepting the cookies always. so invoking actually the URL and then accepting the cookies and then doing this and that. And we have to create manual or automated test scripts, which Playwright can run. So we have actually to bring down the high-level test cases to low level and create test data. In our case, we do have the productive glossary data in the test environment, so it's rather selecting the test data, and acquiring and verifying the test environment is, in our case, not so important because we do have a test environment. So these are the activities, and then finally we assemble the test suites. So here again, the test cases are the main input, so they are our user prompts in terms of GenAI, and we have additional inputs like test data requirements, which we can use as user prompts or RAG, and the system prompts have to contain the knowledge how to automate, so the automation strategy. So for instance, if you have a high-level action described, like for instance, change the settings to search in the definition instead of the name, then it has to understand it. It has to find the place on the GUI where to click and to execute this action, right? So this knowledge should be generated by system prompts. Let's look at how it works in our case. So the test procedures are created in our tool by using the final states of previous features as precondition. In this case, for instance, there is a feature called start, where you can accept or deny the cookies and start with a different URL, for instance, and GenAI automatically generated some final states, which it published, meaning that it maintains a list of public states that you can use in subsequent features, right? And so that's the chaining. And then the most important and most labor-intensive part comes, namely creating automated test scripts on the test interface level. For this, you need a test interface, in our case, the GUI, but it can be an API or some other test interface. And the model-based test tool can send the high-level test cases with the high-level keywords to the generative AI, and generative AI has to search for the corresponding actions and verifications on the test interface, as well as the suitable test data to use, and generates the test automation scripts. So Harmony is using Playwright's area snapshots. That's how the developers did it, and also the main object model. And then we generate a test script which can be executed by Playwright. So how does it work in practice? In my example, I start the automate feature with the model, and the model asks me to prompt the generation. And here, as you can see on the small butterfly highlighted in pink, I selected the option to generate it automatically by GenAI. Now, GenAI looks at the first action. In this case, it's a very simple action, do nothing, and then it starts to find a way to resolve it. And finally, it will click on a place which is inactive on the screen and continue with the verifications. Right? So this is the part where it needs most time, but it's still quicker than I could do it. So generating test automation scripts takes a couple of seconds per keyword, per high-level keyword. And so the total effort is to generate a mid-sized feature like ours about 30 minutes. Sometimes I have to intervene and tell the machine where to click and how to find, for instance, if it wants to change to German language from English, where to find the language selection. But usually it will find its way, and sometimes it's even smarter than I could do. So for instance, we also support right-to-left scripting languages like Hebrew and Arabic. And how do you verify that the text is scripted right to left? Well, AI knows. I don't. When it comes to re-execution, since we generated test scripts for the automation machine, and this is very important to do it, then you can run all the test cases automatically in a couple of seconds per feature. And the maintenance is also supported. So if you're practicing test automation, you know that as soon as the developers change something, a very little bit of thing, regenerate the GUI, the test automation script won't run anymore because some domain objects have different names, are difficult to find. And this system supports me very well in that it stops at the place where something has changed and asks me whether it should regenerate that step. And if I say yes, then it will find its way itself. So as a result, as a test analyst, I'm not really a test automation engineer, but I was 4 times faster than a test automation engineer. I guess a test automation engineer needed at least half a day to script all this, and I was done in 1 hour. And in addition, by systematically applying these test techniques in the first part, in the automatic test analysis, I achieved the test objective more effectively. So I have a high level of coverage. I can find many defects with a low number of test cases, and this very quickly. So my conclusion was in this experience that GenAI can boost the efficiency of dynamic testing dramatically. In addition, it delivers documentation for free, traceability for free, which I didn't even write down. But I'm not automating. I'm prompting the system to automate, right? So I sometimes have to write in the requirements things that are prompting the system. But remember, if you don't have reasonable test basis, if you don't have a reasonable test process, then you end up with what test automation pioneer Mike Fuster pointed out: automating chaos would just give faster chaos. And remember, GenAI does not replace test analysts. I think everyone is agreeing on this. Human in the loop, and actually I would say expert in the loop, remains indispensable. You have to verify what GenAI generated. It's always artificial intelligence. It can always have bias and hallucinate. But if it's well done, the model is good, then it rarely happens. You should never blindly trust the artificial intelligence. The system prompts must be comprehensive and well structured. We arrived at this point with the developers of Harmony, where the system prompts were so extensive that the generative AI, so the AI system, began to forget what it was told in the middle of the text. So they had to restructure it and to select it very organized, and organizing test cases into test procedures and selecting and applying test techniques is then working. And finally, what the developers also explained to me is that it counts which large language model you use. In our case, only Anthropic Claude Sonnet was meeting our needs to review the specification, to select test techniques, to generate models, and to organize them. Other LLMs failed in one or the other, either by generating too many test cases or by just ending in endless loops or ignoring things that are important and so on. When you start prompting, it is, however, very useful to use another LLM to ask it, how should I prompt this Claude Sonnet? And Copilot helped very much. So these are some of my experiences I made, and thank you very much for your interest, and I'm happy to answer your questions.
Thank you very much, Matthias, for sharing experiences and lesson learned from the ISTQB Glossary project. I can see we have some questions, and yes, did you encounter hallucinations or bias in generating test cases?
Yes, I did. And I have to improve my requirement specification to avoid them, because sometimes it expected some behavior. For instance, if you don't select any of the attributes when searching in the glossary, then it assumed that you will get an error message. But we don't get an error message because the developers implemented it differently. They said, okay, then we will return to the default settings, which is not very logical, but I accepted it in the beginning, and now in the regression testing, I had to accept it again. Yes.
Thank you. And another question that we have, what if I just use ChatGPT to ask to generate test cases?
Try it and you will see, because in my experience, if you do it, so using just a general model, it can be ChatGPT, it can be any other one. It will generate many test cases, much too many, and they will not be well written. So they will not focus on the main defect risks or failure risks. So you will have much work to do afterwards, because you have to run so many test cases, you lose your traceability, you don't know. So yeah, they can do requirements coverage. That's what they usually do, but they usually miss some critical combinations, test cases, and yeah, so it will be a testing of poor quality.
Thank you, Matthias. And the other question, do you need to code the test automation script?
Basically not. This is a no-code test automation. And basically you just, as I showed you, you just let the GenAI analyze the test interface and do the coding itself. But sometimes you need the support of a test automation engineer. What I didn't explain here, but sometimes there are complex. Let me give you an example. The expected result is that some icon does not appear on the screen. And when you want to generate it, the AI doesn't know how to check it because it's not on the screen, right? So this is where a test automation engineer comes into the picture and should support. But it's it's not a general case. So you need much less test automation engineering and coding skills than usual.
Thank you, Matthias. It was very helpful. Quick reminder, if you enjoyed Matthias' presentation, don't forget to vote for him by scanning the QR code. As we are getting closer to the end of A4Q Testing Summit, I would like to take a moment to thank all our speakers, attendees, partners, moderators, and especially my colleagues behind the scene, especially Kenza. And if you missed any session or would like to watch the sessions again, or if you want to share these sessions with your friends and colleagues, are available on our website and YouTube channel. Thank you, Matthias. Thank you, everyone, to joining us, and enjoy the rest of Summit.
Thank you very much, wherever you're watching us. Bye-bye.